Let's go over the product rule for exponents. Now, the product rule is very commonly used in algebra, and let's say we are multiplying two exponential expressions, 2 squared times 2 cubed. Now we know that 2 squared is the same thing as 2 times 2, and 2 cubed is the same as 2 times 2 times 2. So when we're multiplying these two, we are multiplying 2 2's and 3 2's, or 5 2's in total. So this would equal 2 to the 5th power. Now if you notice the exponents in our original question, the exponents are 2 and 3, and the exponent for our answer is 5. And you'll see that 2 plus 3 equals 5. So we added the two exponents in the question to get our exponent in our answer. And this is true for other terms as well. So let's say we have 3 to the 4th power times 3 to the 5th power. And if you multiply this out, this is 4 3's, 3 times 3 times 3 times 3, times 3 times 3 times 3 times 3 times 3, 5 3's. So if you multiply these two, you'll get a total of 9 3's. We're multiplying 3 9 times. So when we are multiplying two terms of the same base, both of these have a base of 3, we are basically adding the exponents to get the exponent of our answer. Now this also works with variables. X to the 4th times x cubed is going to equal 4x's here times 3x's here. So that's going to be a total of 7x's. And again, 4 plus 3 equals 7. So the general rule then follows. If we have x to the power of a, where a is any number, times x to the power of b, where b is any number, that is going to result in x to the power of a plus b. Now notice one important thing here is that the bases need to be the same. They both have a base of x. This does not work. Let's say if we have an x to the power of a times y to the power of b, we cannot apply the same rule here because they have different bases. But as long as we have the same base, and if we're multiplying those two terms that are raised to different powers, or it can also work with same powers, we can just simply add the exponents. And this is called the product rule.